Hello everyone, I am Kyoung-Hee Kim, a professor of architecture at UNC Charlotte. I will guide you through sustainable building materials, focusing on timber structures. We reference key texts such as Materials in the Environment by Michael F. Ashby and Turning Point in Timber Construction by Ulrich Dangel, which provide insights into eco-informed material choices and the evolving timber economy. We discussed this slide in the previous videos. The slide introduces the major building systems in a building: site, structure, enclosure, services, and interior systems. Each category includes various elements, and the slide highlights how material choice impacts sustainability. Under the structure category, we see a comparison of embodied energy per square meter for common structural materials, roughly steel, 1.2 gigajoules per square meter, concrete, gigajoules per square meter, and wood, only about 0.67 gigajoules per square meter. Notice that wood's embodied energy is the lowest. Timber generally requires less energy to produce, which is a key sustainability advantage. This sets the stage for why we focus on wood in sustainable construction. Now we turn our focus to wood as a structural material. This slide lists the many forms and uses of wood in building structures shown on the left and walls and floors applications shown on the right. Primary frames refer to using wood to create a skeleton of columns and beams. These timber frames carry loads through linear elements and joints. Glulam, glue-laminated timber, is made by bonding together layers of lumber to create a single strong beam or column. Solid sawn lumber refers to the traditional wood pieces cut directly from logs, which, while used for centuries, are limited by the size of trees and natural defects. Composite lumber combines wood with other materials, typically a timber element reinforced with steel or concrete in some way. For example, a flitch beam is wood sandwiching a steel plate. A wood-concrete composite floor system is where a concrete topping works together with a timber slab. Different load-bearing walls and floors are shown on the right, such as cross-laminated timber, laminated veneer lumber, laminated stranded lumber, parallel stranded lumber, and mass plywood panel. All these engineered products share a common principle in that they maximize the structural potential of wood by combining thinner wooden layers into a thicker composite panel. CLT is manufactured by laminating boards together in perpendicular directions, which becomes flat, stiff panels. CLT is the most revolutionary wood product, great for large surface elements like load-bearing walls and floors. Each of these panels in framing and surface applications is essentially wood that has been engineered and assembled in a special way to make it stronger or available in larger sizes. This slide illustrates the relative spanning capability of different types of wood beams. A solid sawn wood beam, a single piece of lumber, can only span a limited distance before it either deflects too much or can't carry additional load. The chart on the left shows spans between columns on the horizontal axis and the depth of engineered wood beams on the vertical axis. For example, a 12-meter span requires 610 millimeter deep glulam beams. The figures on the right illustrate different engineered beam sections. Glulams are made from many laminations of wood glued into one member. Composite or engineered beams incorporate steel plates between lumbers, which can handle the longer spans. A deeper beam can span a longer distance, and a bigger column can support a larger floor area. However, the trade-off is that bigger structural members occupy more space, potentially impacting occupiable space and ceiling height. Therefore, spatial efficiency needs a thorough balance between beam span, beam depth, column size, and structural base spacing. Now we consider wood columns. The chart on the left correlates different wood column sizes with the tributary floor areas they can support. For example, a 343 millimeter, 14-inch engineered wood column can support a 279 square meter, 3,000 square foot tributary area. The chart on the right also shows unbraced column heights for engineered columns. For example, for a 279 square meter, 3,000 square foot tributary area, a 343 millimeter, 14-inch column can be taller than 4.9 meter, 16 feet, without requiring bracing to prevent buckling. The data here, taken from design guidelines, essentially gives rules of thumb for selecting a column size for different structural bay options. CLT panels are used as floor slabs and roof decks in buildings, taking the place of concrete slabs in many designs. They have the advantage of being much lighter than concrete, while still providing rigidity and fire resistance. Like heavy timber, the thick wood chars on the outside in a fire, insulates and protects the core. Typical CLT panel makeups include a 3-layer panel at about 100 mm thick, a 5-layer panel at 180 mm, a 7-layer panel at 240 mm, and a 9-layer panel at 300 volts-meter thick. Using the chart on the left, a 240 mm thick, 7-layer CLT panel can span 7.3 meter. Thicker panels with more layers can span farther and carry more weight. CLT floors are typically prefabricated in a factory to the exact dimensions needed, with openings for stairs or ducts pre-cut and then craned into place on site. This makes construction very fast. It is an innovative, sustainable solution in heavy timber construction, giving us the ability to build large, open floor plates with sustainable materials. Completed in 2022, Ascent is a 25-story residential high-rise about 86.6 meters that demonstrates how far heavy timber technology has come. The tower structure is a hybrid system consisting of above a concrete parking podium, and the upper floors are built with a mass timber frame. It uses Glulam timber columns and beams along with CLT panels for floors and walls, all tied into a concrete core that contains the elevators and stairwell for added stiffness. Ascent surpassed the previous record holder, Norway's Mjøstårnet, by a small margin to claim the height title in the world. Mjøstårnet is an 18-story mixed-use building that reaches about 85.4 meters in height, and prior to Ascent, it held the title of the world's tallest timber building. The building demonstrates Scandinavia's leadership in timber construction. It houses retail, apartments, a hotel, offices, and even features a swimming pool, all structured mainly with Glulam columns and beams, along with CLT panels for floors and cores. Since completion, it has become a case study in reducing carbon footprint. Estimates have shown huge embodied carbon savings compared to a typical concrete building of similar size. Mjøstårnet demonstrated that a high-rise building can be constructed using almost entirely timber framing. The tower has Glulam trusses bracing its exterior and CLT floor and walls. CLT interior finishes provide warmth, brightness, and aesthetics, harmonizing well with the natural surroundings, literally a tower by a lake. The tower is a flagship example of sustainable architecture, showcasing the innovative use of renewable materials. The Schönbuch Tower is quite different from the previous buildings. It is essentially a scenic lookout, rising about 35 meters tall in a natural park. The tower structure, located in a nature park, is notable for an elegant combination of timber and steel structures. The tower has 8 Glulam masts arranged in a circle, which supports 3 open-air viewing platforms at 10 meter, 20 meter, and 30 meter above ground. Additionally, the external steel cable serves as bracing and lateral stability against swaying. 2 spiraling staircases, also supported within this timber framework, allow visitors to climb to the platforms. The horizontal platforms are tied into both the timber masts and the cable nets, so everything works as one system. This project is a true composite design. The natural wood of the masts and the scenic context emphasize that this modern structure blends into its environment materially and visually. Key takeaways: 1. Timber is a sustainable construction material because it has lower embodied energy and carbon footprint than steel or concrete. 2. CLT, cross-laminated timber, is a revolutionary engineered product that can span entire floors and walls. 3. Heavy timber high-rise buildings demonstrate that sustainable wood construction can meet the demands of contemporary sustainable skyscrapers. This video was supported by UNC Charlotte in collaboration with the US ASEAN Smart Cities Partnership. For further inquiries, please contact Kyoung-Hee Kim at UNC Charlotte. We appreciate your interest in sustainable timber structures.